Yes, so my name is Chris Manson-Whitton from Progressive Energy. Our mission as Progressive Energy is to take millions of tonnes per annum of CO2 out of the energy system, and we were formed 25 years ago, it's our 25th anniversary this year, to do CCS and hydrogen. So hopefully our time has now come. It's not just those, but those are the key areas that we are involved in. And very interestingly, from the discussion this morning, there was a talk about how do you make big projects happen and the importance of collaboration. But actually, I'd say also the importance of catalysts. So you do need big companies in order to make things happen. They've got the heft, the power, the financial ability, but actually you need the catalysts to get projects going. And that's what we like to think of ourselves as at Progressive Energy. Now, as I start, this is a graph, I mean, I've shown it many times. I will note it is slightly out of date, but actually I don't think it makes a huge difference, and you'll see though why I want to use it. It is a chart from the Committee on Climate Change, and that is looking at the UK territorial emissions of greenhouse gases over a period of sort of almost 2 decades. And you can see that we have made very good progress. Yes, that isn't going quite up to date, but to be honest, the last few years have been a bit odd in terms of our economic productivity and things like that. But you can see we have made very good progress on our territorial emissions. What is not necessarily as good is what our UK consumption emissions are. And predominantly what that is adding on there is the emissions embodied in the stuff that we use. And I think we can take away a couple of really important pointers from this. First of all, it goes to demonstrate just quite how much emissions are embedded in that stuff. So whether it is the foundation industry, so the core materials that we use to make things, or whether it is indeed the process of making things that we all use and consume. So first of all, the magnitude is important. But I think the other thing it tells us is there's a real economic opportunity. This is stuff that is made elsewhere around the world where we have been out-competed in order to actually deliver those things. But as we move to a low-carbon economy, the driver will be to get that stuff to have a low-carbon impact. Now, if we have the infrastructure, the facilities, the desire, the regulatory framework, we have the ability to tap into that market. And if we can decarbonise our industry in our jurisdiction, and I'm talking here in the UK, but the same flows for any country where they have those kind of policies, that is a market that can be created. This is not just an environmental story, it is an economic story. If we look at Chris Skidmore's report, he very much drew that link between the two. I just wanted to use that as a bit of backdrop. I will now tell you a little bit about Hynet. Some of you will be aware of the project. I will give you a kind of overview of it. But in the course of doing that, I will also update you as to where we are. There's lots of exciting things that have been happening over the last few weeks, let alone over the last few months. So Hynet is a track 1 industrial cluster. That means that the UK government has selected, and in fact that was October 2021, selected Hynet in the Northwest as one of its first 2 industrial decarbonisation clusters. And the core providers of that infrastructure are shown on the left-hand side. It is the consortium that is delivering that. So ourselves, as the catalysts, as I talked about earlier, E&I as the provider of the underlying CO2 transport infrastructure, and that is the foundation upon which the rest is built, because that is taking away CO2 and permanently storing it. But then that infrastructure goes more widely. So yes, there are users of that infrastructure, we'll talk about that in a minute, but one of those users is the production of low-carbon hydrogen, and then with low-carbon hydrogen also comes infrastructure. How do we get the hydrogen from one place to another? How do we get the benefits of hydrogen, which is large-scale volume storage, so that then you can provide a new low-carbon energy infrastructure? But what is really key is this project is led by demand. What you can see on the right-hand side are the users of that infrastructure, and they're broadly divided into 2 groups. There is a group for whom they have unavoidable CO2 emissions, and what they want to do is to capture them and sequester them permanently. and a group for whom what the most economic and sensible thing to do is that they currently burn a fuel in order to do whatever their process is, and by taking a low carbon fuel they can transition, and by doing so they go low carbon, effectively taking low carbon hydrogen. Yes, at volume initially from blue hydrogen, from CCUS enabled hydrogen, but increasingly over time there will be a transition as the form of hydrogen changes. But you can see some really big brands here, and right at the end I'll do a short 2-minute video which hopefully just gives you some insights from some of those users as to what the system looks like from their perspective. So this is what that infrastructure is. We are looking to ultimately generate around 4 gigawatts worth of low carbon hydrogen production, which will collect all those industrial and power and generation plants. It will be connected via a large scale hydrogen pipeline distribution system, new build distribution system, a hydrogen storage capacity, which really uses the capabilities that we have in the Northwest in terms of our geology. And then we have a raft of industrial capture facilities with the transport and storage of that CO2 in order to enable the infrastructure. So I'm going to pick through each of those elements. But before I do that, I need to then update you as to where we were on the announcements that took place about a month ago. So those of you who are listening here in the UK, we had our spring statement, and the Chancellor announced £20 billion worth of funding for CCS and CCS clusters. That is game-changing. I've been involved in CCS since 2005. We had a previous competition that was around 2010 to 2012, which then moved on to 2015 and then stopped. That was £1 billion worth of funding. This is £20 billion worth of committed funding, predominantly revenue funding rather than capital funding, which is exactly what we as industry want. So that's one big game changer that happened then. And then about 2-3 weeks ago, the capture projects on that selected cluster were then announced too. And as far as Hynet was concerned, we actually had a very, very good set of announcements. 5 of our projects were then selected, and I'll tell you a little bit about them, as capture projects to be taken into the next stage of negotiations with government. And between them, they will capture around 3 million tonnes of carbon dioxide from industry each year. These will be the first projects off the rank, along with a few projects from the East Coast as well. They will be the first projects off the rank industrially in the UK. So this is the CO2 transport and storage, and this is led by Eni, and they own the offshore fields in Liverpool Bay. They are disused gas fields, or gas fields coming to the end of their economic life. They are converting them in order to be able to take CO2 rather than producing gas. And with that, then also is required a CO2 pipeline. What you can see in red is an existing pipeline used for natural gas, which will be transformed into a CO2 pipeline. And then in blue is a relatively short section compared with the overall length, including offshore, of new build CO2 pipeline that will be needed. The engineering design is well advanced. We are in the consenting process already. That has been submitted, and we are in the determination of that at the moment. And as far as the offshore is concerned, that storage license has already been awarded because this is one of those early projects. What is interesting then is to look about the projects that are connected. So different types of capture projects that will be connected to the infrastructure, denoted by the colour, and then the stars actually denote the projects that have been awarded the position to go into negotiation for what we need. So starting over on the left-hand side, we have Padeswood Cement. That's a facility where we will be capturing 800,000 tonnes of CO2 per annum. The cement sector accounts for somewhere between 7 and 8% of global emissions, so is an absolutely vital sector to decarbonise. But also importantly, because of the chemical process that takes place, inevitably produces CO2. Yes, you can fuel switch away around a third of those CO2 emissions by using biogenic feedstocks and things like that. But fundamentally, 2/3 of that comes from the chemical process. You have to capture CO2. This will be a world-leading plant that will be able to do that. So that's Padeswood Cement. There is actually another small lime and cement sector project as well, which is Buxton Lime Net Zero. That's a relatively small project looking at some quite innovative new ways of capturing CO2 from that process, again, underpinning that foundation industry. We've got Up at the top, we have Runcorn Energy Recovery Facility. So that is the largest energy from waste plant in the UK, emitting around 1 million tonnes of CO2. That will be captured and permanently sequestered. What is really interesting is, of course, a big chunk of that is actually biogenic in ultimate source. So when you take your residual waste, around 50% of that has come from biogenic materials. So arguably, not actually part of the funding regime, this is funding as an industrial project, you are actually getting a level of greenhouse gas reduction technology almost for free launching in terms of that. And then we have another slightly smaller but still significant energy from waste plant with Encyclis, which is around 400,000 tonnes that will also be connecting to the infrastructure. And then finally, we have the low carbon hydrogen facility by Vertex, which is a joint venture between ourselves and SR, the refinery. So I will now start picking through each of those, or picking through from Vertex onto the next part of the infrastructure. So as Vertex, we undertook a FEED, which was now completed at the back end of 2021. So it is the only large-scale CCUS-enabled hydrogen plant in the UK to have totally completed its FEED for its first line. And ultimately, we'll be looking to deliver a gigawatt of hydrogen production in the first wave, which is split into 2 lines. Now, that first line of 350 megawatts has already been invited to enter into negotiations with government. We are in a position where we submitted our consents almost 2 years ago. We've done the FEED. That project is going to be ready to go and first off the rank. I'll unpack a few of the challenges a little bit later. Just to demonstrate we are not purely about CCUS-enabled hydrogen, ourselves in a collaboration with Statkraft and Foresight are developing a suite of electrolytic hydrogen projects as well. So that includes a 28 megawatt project which will use renewable electricity from the Foresight wind farm that you can see there, Frodsham. And that is an initial phase of comprising around 100 megawatts by the time you add the other projects in, that will reduce the carbon intensity of industrials using that low carbon hydrogen. How do we get the hydrogen to its users, and how do we develop the infrastructure? Now, the first Vertex line is just delivering to adjacent users of the Vertex facility. In order to reach that wider list of users, we need a hydrogen distribution system. This is being delivered by Cadent. The FEED is well underway. The DCO consultations have already been completed. That will be going in for application during the course of this year. This will be the first 120 kilometre dedicated hydrogen pipeline in the UK. To do that, we're going to need a business model. We'll talk about business models, no doubt, but actually this business model is one of the less developed ones. How do we get this funded in order to make it happen? But government sees the importance, we need that to happen. And similarly, we have Innovin, who will be providing geological storage of hydrogen. That FEED engineering is underway, is pretty much completed. In fact, its consents have already been granted because it's transitioning from a natural gas consent to a hydrogen one. The volume of storage in there is transformatory. That will be storing 1,300 gigawatt hours of energy. If I were to put that in other terms, if you turned every passenger vehicle in the UK into a Nissan Leaf at around 40 kilowatt hours of storage in those vehicles, that would be about the same amount of energy storage as you get from this facility here. It will make a noticeable difference to the UK's just straightforward energy storage, energy reserves, let alone the fact that it's low carbon. And then how do our users gain confidence that they can be able to use that hydrogen? So we've undertaken trials at Pilkington, and I know we've got Paul speaking a little bit later. So we undertook trials, now 2 years ago at the Greengate Works, so looking at taking their existing furnaces and running core parts of those at 100% hydrogen and running the whole facility, undertaken by Tommy, who will be speaking a little bit later, on a blend of hydrogen as well. We also did work at Port Sunlight, so the Easter before last, their entire site for a period of a week, 10 days, all the steam raised across that site was on 100% hydrogen. We've now then done some further feasibility studies at some well-known names that you can see there, under the IFS programme, in order to work through with these organisations. What are the barriers? How can they convert to run on 100% hydrogen? And what we've got there is Steve Rotherham, who's the Mayor of Liverpool, up at Pilkington and seeing the trials as we were running them. Now, I'm now going to just pick up two things. First of all, where are we and what are the challenges that we see, which I'm sure we're going to pick up in our discussion, and then a very short video. So planning and consents, we are well advanced in those, but they take time. I have to say one of our regulatory bodies has taken almost 2 years to respond to statutory consultations. Not because there were big issues that were raised, but just the time it has taken and the level of resource that they have. That holds things up. Now, the fact that we submitted our consents almost 2 years ago puts us in a really strong position, but it is a challenge. We do need the legislation. The energy bill here in the UK is absolutely vital. Some really important things going through, and that must land because that is what enables us to sign commercial contracts. And again, I think in the discussion, no doubt we'll pick up the different business models to enable it, where the risks are, where the opportunities are, and how does the UK position against what's happening globally. So before I finish, and you should never work with children, animals, or videos in presentations, I'm really hoping that this is going to work.
Here in the Northwest and North Wales, we sit at the heart of the UK's manufacturing economy, creating many of the things we use in our daily lives. The UK business sector accounts for around 1/5 of the UK's greenhouse gas emissions, and reducing these emissions to net zero is a tough challenge, but Hynet is making it happen.
Decarbonisation is very important to us at Pilkington. Low carbon hydrogen gives us a way of instantly decarbonising how we make glass. We were the world's first glass manufacturer to trial hydrogen power, and we were impressed that high volume production at high quality continued unabated. Our partnership with Hynet will put us at the forefront of innovation as we take this step to decarbonise how we make glass.
At PepsiCo, we're fully committed to greenhouse gas reduction, which is why we're aiming to be net zero by 2040 as part of our PEP Positive sustainability goals. With many much-loved brands from Walkers and Doritos to Pepsi and Quaker, we want to focus on powering how we produce our snacks and beverages in a sustainable way. Here at our site in Skelmersdale, Hynet gives us the capability to use low-carbon hydrogen to produce our snacks, helping us meet our carbon reduction targets by 2030.
Hynet gives us the opportunity to use low-carbon hydrogen at our Wrexham and Trafford Park plants. The hydrogen will be generated just up the road in Ellesmere Port, giving us a source of locally produced fuel. This allows Kellogg's to decarbonise how we produce our much-loved products, from cornflakes to crunchy nut.
Kellogg's is committed to increasing the amount of low-carbon energy we use in our plants and reducing our carbon footprint wherever possible.
At NSERC, we will use Hynet's low-carbon hydrogen in our furnaces to create billions of ultra-low-carbon glass bottles for wine, beer, soft drinks, water and food. This means we will grow as a business, creating at least 200 jobs and future-proofing existing roles.
Hynet will help us to decarbonise so we can meet our zero emission targets and create the world's most sustainable glass bottles.
From the mid-2020s, Hynet will enable the UK's vital industry to move from fossil fuel gas to low-carbon hydrogen. It will also provide a route for companies to capture and lock away their carbon emissions. The North West and North Wales are at the forefront of the UK's low-carbon hydrogen transition. We are proud to be making it happen.
Hopefully that's given you a window of how our users see Hynet. And I think two important things from there. First of all, these are products that we are using on a day-to-day basis. So when we are engaging with those around us, these are the kind of messages that we can be putting out. This is how we can decarbonise. And secondly, I hope you took from there, yes, there are core financial decisions that are driving big companies to work out how to decarbonise. But there are wider drivers. It is not just stick. There is a carrot. These companies' customers want a decarbonised solution, and that's what we can provide. Thank you.